just to get you familiar with what context I'm going to talk about, it would be majorly focusing on tracing aspect of it. So um, just an intro to, yeah, this is me and this is my colleague Gaurav Sitlani, and we worked on this together. And yeah, uh, I work as a cloud storage engineer in Koor Technologies and also contribute to Rook project. I used to work in Redos and RBD, RBD earlier, and yeah. So in this talk, we'll try to cover briefly give an overview of what tracing is and what like open telemetry, Jaeger tracing, which is what we use in Ceph for basically as a backend and like providing tracing services. What is the current state of tracing in Ceph in general and what it holds for Rook as well. And then we did some tests in Rook Ceph clusters related to tracing. And what were the findings that came out of it? We'll try to stress a bit on that as well, what it holds in future for Rook as well. And yeah, I mean, summarizing those aspects and having a discussion around it, hopefully at the end of the presentation. So yeah, I mean, just to understand why did we need tracing, we can stress a bit about debugging scenarios in Ceph in general that we deal with. So one such scenario is OSDs becoming slow or maybe even having slow operations around OSDs. So there could be various scenarios originating in OSDs that might lead to it. There could be block of write waiting on it. There could be OSDs dying out, maybe due to hardware failure, maybe due to software failure, or even a heavy recovery operation going on. There could be an object that's lost, unfound, or not being able to get mapped on the Redos layer. And there could be topology-based things happening that might be overloading some of the OSDs, and maybe something might be faulty. But yeah, it's a really hard problem to dig into the logs and try to find out what is happening at what particular point of time. And yeah, just I mean, if somebody is really a beginner and just want to have to pinpoint where to look at, it can get a bit tough. So that was the problem. Yeah, I mean, yeah, I highlighted a bit on those aspect, debugging. So if you enable debugging in Ceph, there could be tens of thousands of lines of code that you might have to traverse through to get through the root cause of the problem. Not everybody has the first-hand Ceph expertise to deal with such scenarios. If somebody is just an administrator and they are working maybe round the call and they do not have much expertise with Ceph and something is going out around that's not particularly right, how can they narrow out those, like how can they actually act on those conditions and pinpoint, okay, yeah, I need to figure out, I need to go to that node and check out that OSD. So yeah, we try to reduce the first contact point by using tracing as a solution. I'll highlight a bit more later on that. I mean, also in the production cluster, not everybody can have logs enabled all the time. There are thousands of OSDs. How would you make sure what went wrong? Also, this is not a monolithic architecture. We are talking about thousands of distributed resources. So there could be a thing like there is no single point of failure. There could be multiple resources going down. And then again, there comes a point, not everybody has that Ceph expertise at their disposal to make those connections and understand how things are moving and what should I do. So for that, that was the problem, and that's why we tried to bring tracing to Ceph. And uh, uh, in contrast to logs, what tracing brings to our table is it certainly, if you cannot enable debug logging on production cluster at higher level, but you can certainly have an always-on tracing. Um, um, uh, Always-on tracing, which would be comparatively a low performance overhead. Um, yeah, there could be an always-on tracing in production cluster, and that might help you understand even the resource requirement, or in general, give you the overview of the client or the I/O operations going on in your production clusters. Now, the use case is not limited to just that. In tracing, we can also have sampling strategies. So it would not be like there are thousands of requests going on. So every request would have a trace associated with it. We can make use of these adaptive sampling strategies, which would actually make you kind of probabilistically pick up a trace. And of course, that might not be the ideal solution, but would certainly help in reducing the overhead, as well as giving you overview of the system as well during the production cluster runtime. And the solution that we are using is de facto standard that's been used in the industry. So if anybody is going with a solution, they are going to adopt generally what we are working with in Ceph. I'll highlight a bit more on that later on. And in existing Ceph architecture, we still have traces, or still there is a service that previously people used to use, that's Zipkin, and the OpenTelemetry Jaeger tracing infrastructure has backward compatibility with it. So that means if you have existing traces in your code base, you can still work with it using OpenTelemetry with it. So just to give a brief overview of what OpenTelemetry Jaeger tracing is. So it's made up of two components, which I can say OpenTelemetry is the vendor agnostic API. By that, I mean you can use this SDK to write instrumentation in your code. These APIs are not relying on any backend. So as I said, Zipkin is one such product which it is backward compatible with. The service that we went ahead with is Jaeger, which is basically using gRPC and Thrift protocol to kind of send these traces and collect these traces, and in general collect these traces from OpenTelemetry and kind of stitch them together and actually formulate a trace and provide a UI. So it's already a CNCF incubated project, and also been actively developed. So coming to how things work and what are these traces that I'm talking about. So as you see, there is a graph, kind of tree-like structure. So every round circle forms a span. A span is kind of the smallest unit in a trace, and it kind of is giving us the context at that particular point of time about that operation. So it generally contains operation name, and when the process started, when it is getting finished, along with any artifact that you want to add to it in form of tags and logs, and key value pair that we add in as a baggage item. That can also be something that Jaeger instruments as well. So you can see multiple artifact that the user adds, as well as what the service adds. And once we kind of, these are have unique identifiers, and how we write the code is if that's the A node acts as a parent to B, and its context ID, basically we mentioned that A is the parent of B, and basically flow from there. So once that is mentioned, it will fetch the context ID of this span, and basically that will link to B, as B is the child of A. And there are, in this way, the context is being propagated, the spans are generated, and in the backend, that's what Jaeger does. It takes these spans and then maps it. Okay, you are the parent, you are the child of this unit. So that way, we get all the metrics as well as the context propagation, along with the dependence and workflow of the code. And so, as I said, there are headers with trace IDs, and then we have our code instrumentation, which adds the context to the span, and these are part of the tracing SDK. And once, the tracing, it completes its whole operation. It sends the traces to the backend service, which will act on forming the traces, in our case, Jaeger. So the open telemetry collector and Jaeger, how does it work with the code? Basically, our app has instrumentation. Using the open telemetry SDK, we use this along with the sampling configuration, based on which we'll decide, okay, this is the span. Do we want to keep it? Do we want to transfer? Do we want to even propagate the children, it to the children? Based on the sampling strategy, we make a decision. No, we do not want that overhead, or we do not want to carry on with sending the traces, or we want to just pick up one or two spans from a large number of requests. Or we can always go ahead with a constant sampling rate and send all the traces. It works with the sampling configuration and sends it to the open telemetry collector. Now, the open telemetry collector is kind of a sidecar, or the agent which is listening to these spans, and then once it has the spans, again, based on the sampling configuration, it makes the decision and again sends it to the Jaeger collector, where again, based on the sampling configuration, the traces are stitched together, and that's how basically we kind of have the sidecar deployment architecture in Rook Ceph. So the first diagram would be valid in our case. I think. So apart from the collector and Jaeger collector, there is a Jaeger query and the database. So once the Jaeger collector has stitched together the spans, it stores the traces in the database, and once there is need, the user can query these spans from the Jaeger UI. So this feature is available in Reef right now. I did some testing and found out like it would be easier to someone to get started with it using debug. Debug builds for Ceph, but since Reef is going to come soon as well, it would be interesting to have this adoption in Rook Ceph as well. So there, I had I tried to record the setup, how things look when we set up things in the Rook Ceph cluster, but I'm not sure whether I'll be able to show you right now. But just talking in general about the architecture of deployment, as we saw, there is a Jaeger agent or the sidecar, which is listening to collecting the spans. So in general, in Rook Ceph, we have the OSDs or RGWs or the resources that we have instrumentation in. So how we add Jaeger services into them is basically have a sidecar injection in them, that the sidecar agent would actually be listening to these spans, and along with kind of collecting these spans, and in the same production cluster you can deploy use Jaeger operator. There is an operator available, and there is one click solution, and it will deploy the kind of services needed for getting started with tracing in Ceph. So it will basically deploy a Jaeger agent right now, a collector, and a UI. So we are going to replace the Jaeger agent with Open Telemetry Collector. That's also suggested in Jaeger project, which would work similar to Jaeger agent. And once the setup is done, basically when you create a RGW instance, as in when you do normal operations like S3 listing of buckets, or uploading a file to S3 bucket, or even in OSDs directly, maybe running LibreDOS, or uploading a object, or doing some perf testing in them. You can see the traces. I might be having how the traces look like right now. Okay, I do have the setup guide, but maybe the cooler thing would be showing how the traces look like. Okay. Yeah. How can I do that full screen? Uh, oh. Oh, you can see it? By the way, can I get the full screen of this? Is the full screen maybe here? Can you increase the quality? Uh, Maybe from the settings it's already full. And can you do it from the start? Yeah. So this is the create request out of all the operations that you see inside the OST as well as RGW code. This is the verify permission or execute. I tried to list the buckets and see what operations were going on. I actually ran into an issue trying to upload the file, and this was good enough for me to verify that I was able to kind of something was wrong with my S3 configuration, and still I was and the basically the AWS or the S3 API was working fine. But that's just a small use case. In totality, we can use this also to kind of do performance testing of new features that we add to Ceph, or even try to get someone who understands Ceph internals better, how things flows in general, by having debug builds with more tracing added. Now, we cannot do that in production because in general that would be a huge overhead to kind of have everything orchestrated, but certainly it can help with learning the whole internals of Ceph. So as uh, as I said, this could be a good tool for Rook users. Even as I think in the last session, or it was talking about understanding multi-tenancy, how the features that they are adding with kind of experimenting with Ceph, how they are performing in terms of uh, how long they are taking to execute, or even the matrix. We can add those fields, custom fields that we want. Supposedly, there are perf metrics in Ceph as well. So if we want to add the real-time values of them at that particular point of time, we can do that with tracing services as well. Now, it's an operator pattern, so you do not have to manage a lot of things yourselves. Jaeger already has an operator in place. OpenTelemetry already has an operator in place. So if there are some new updates or better improvements in their kind of services, maybe even sampling, we can just go ahead and adopt it more easily using their operators. What I found was there might not be enough or kind of exposure to how a developer or contributor can use tracing to kind of get started with understanding what they are developing as well. So maybe one area of contribution I can make is in this direction. Feel free to reach out to me related to that as well. And the future scope that I found while working on this was, we right now have to have all the code that's instrumented mention Jaeger as a sidecar injection. So something that I would like to see is maybe Rook taking care of it, or OpenTelemetry collector understanding and taking care of it itself, rather than everybody trying to deploy a separate service for it. More instrumentation in general. Yeah, we have to understand what would be best, what would be the most demanded thing that people want to see in their production clusters at real time, and have those instrumented in our code base. And testing with sampling strategies and playing around that, something that I look forward to as well. And having the CRDs for Jaeger services in Rook Ceph. And yeah, I think mostly those things we can explore in tracing in general, as well as in Rook Ceph clusters. And I think that would be all. Uh, Thank you. Uh, any questions? Yeah. Right.
Yeah, can you explain more the scenarios where you see where it could be useful? I mean, we can think of lots of scenarios in the long term, but I'm curious. So I think you had an example for provisioning a bucket and being able to see the different steps of that. Uh, so like what all steps would we be able to see in that example? I couldn't tell exactly.
So there is, you can gather, like, you can just grep for ad span in Ceph code base. That's basically like what we will be able to see. But you can also test it yourself. What I was able to see is basically it will try to list the operations like execute or go to the list bucket function, and from there there is a unique identity that even maps to the logs in Ceph as well. So you can understand, okay, this is the metric, and this is, if we graph for the same thing in the logs, we can correlate that, okay, this is the transaction that was happening, and kind of like up till this point I was able to see kind of the traces, and from there we can also correlate it to the logs, whether like how things were going. But in general, if you are asking about what functions are being traced in RGW, I think even I'm not completely aware of them, all of them, but you can certainly just grep for ad span and you'll be able to find all the functions, or even just take a look by tracing yourself.
Yeah, exactly. Next question. So everything that we want to trace we'll generally trace them through Ceph probably, and Ceph will need to instrument those things, right? And then the sidecars you're talking about would just be for gathering those traces,
Yeah.
right?
Yeah.
So Ceph really does the instrumentation, and then we can, with Jaeger, we can collect it and visualize it, and
Yeah.
so.
So yeah, that's also there, and there is, I think, auto instrumentation available for other SDKs, but sort of sadly not C++ right now. And in terms of, I think that's why I brought the point of having debug builds readily available than going through the whole cycle of development. So we can, if we want to see traces, we do not want to go back. Maybe in some point we can have conditional enabling of traces by component basis. Also, one thing we can do is we can have conditional enabling based on component basis, as in you just want to see RGW traces, you can have just them enabled. You can have them globally enabled. You can have them enabled on OST level. Other components still need instrumentation, but and also there in RGW code there is an option to disable certain traces, and I found that some of them are disabled by default, but again, if you want to enable them, again, talk to RGW folks, or yeah, have a debug build of your own. So certainly something to ease out from kind of Ceph dependency and having more instrumentation in general.
Right.
Any other questions, Travis?
Yeah, it's a great area for discussion. I think there's lots to. I'm curious to see how it kind of works end to end.
Yeah, I think it was just a quick demo, and I was just trying to record a demo early morning.
Yeah.
But yeah, certainly I think I can show you and even link a demo in the talk as well on it. Yeah, and certainly there would be documentation in Rook Ceph going in as well around how people can get started with tracing themselves. So That's all.
Sounds good.
Cool.
So by traces, you mean like, just to clarify, uh, like there is a process running, and if there is an performance gap, so
Mm-hmm.
we can look back to it and see where it gets stopped.
So that's one of the use case. By traces, I mean it will give you context or at real time overview of the process. So suppose there is an OST input output path that we kind of instrumented. We added traces to it. So it will tell you that okay, now our kind of service, MS Dispatch. There is a MS Dispatch service at OSD from where our first, that's kind of first thing that comes in IO path. And then there are it will go to execute op, and then there at later stage try to submit a transaction. Lots of process going on. You want to see what is happening at what particular time. You can add a context to it. It will just say, okay, at this particular time, I am here. And kind of will give you an end-to-end workflow of how your request went. So if you are trying to list a bucket, it will first say, okay, you are at a RGW function to list a bucket. Then it will move to the libredos layer and kind of translate into read request or write request. Then it will move to the IO path. So you can see end to end how the process is working and then make a decision. Okay,
Got it.
do
Got
I
it.
want to, is there a performance anomaly? Generally, it takes 5 microseconds. It's taking 10. So you can make those decisions for debugging your system.
So do you meant to say like this Jaeger operator is proficient enough to like give the context and trace anything that you want
Yeah, you
apart
have to
from the Ceph
write the
cluster
code,
also?
as in you have to write spans or add traces to your code for it. But once the traces are in place in the code, it will be able to collect those traces, generate those traces, and collect those traces, and try to give you the overview of the system. If my laptop would be working, I can show you some things, but not sure.
No problem. We'll connect it later. Sure.
Yeah.
Thanks.
Yeah.
Just one short question. Thank you. You mentioned that this observability will be available in Reef. I mean, Reef is the
Yeah.
code that will have the capability to instrument all these proofs and all this data.
Yep. So in Rook, we use a kind of Ceph image, and right now we are using Quincy.
Quincy?
If I'm not wrong, Quincy. So Reef would be releasing soon as well. Once Reef is available, there are instrumented code available in Reef version, and you can have kind of there are config options like Jaeger enable and kind of just have a port address for Jaeger to listen to. Those all would be documented in Rook soon. Once you have Reef along with those options and Jaeger resource deployment, you would be able to use these services.
Okay, but that will be only for Rook deployments. I mean, standalone.
No, that's also in Ceph. You can use it using Ceph ADM.
Okay.
There is a tracing services documentation, and if you want to get started, this is just a one-line command. The units that I listed, the resources, everything, it will deploy those resources in the background, so you need not have to take a look into taking care of those. So if you just want to test tracing in general and see, you can certainly try to take a look into Ceph ADM-based tracing deployment.
Thank you so very much.
No worries. No, I mean tracing itself. So he asked, would it be supported with a manageable module? tracing is just the instrumentation. What Ceph ADM is doing is deploying the Jaeger resources, agent, collector, and which are actually kind of forming traces, Jaeger backend and open telemetry. So how we are doing it is using Jaeger operator and open telemetry or collector operator. So that would be better because operators are generally taking care of lots of stuff and lot more maintainable. So it would be better than Ceph ADM. That's a controversial statement, but
So yeah,
more
it's
maintainable.
externally supported right now.
Yeah.
Got it.
So yeah.
Well, it may not be fair to compare Rook to Ceph ADM because Rook has the advantage of Kubernetes. So.
No, it's not the comparison. It's just that they develop an operator, so why not use that operator instead of having the deployment ourselves? So, yeah. Any other questions? No?
If someone wants to use this today with Rook,
Uh-huh.
they can always use
Yeah, debug
custom,
builds.
like
Yeah.
Ceph ref image,
Yep.
the official ones which
Yeah.
released. So they can use today.
Yeah. I actually use that only. So if somebody wants to use production cluster, then I mean, that's why I'm saying it's Reef. So even master is right now kind of in 18th version. That's kind of, it would be cut for Reef. So if you want to test it with Rook, again, you can always have the Ceph debug builds available. Now, those are available at Quay, and all those process would we can I think document it as well, and you can just use those images with Rook to kind of test the deployment in Rook Ceph cluster. That's what I actually did. So good question, Shubham. Okay. Any other questions? No? Thank you.
Thank you very much.